Hello learners and welcome to today's lesson. So in this lesson, I'm just going to be giving you tips on how to score full marks or score maximum marks for your physical sciences paper 1. But to do that, these are the skills that you need for each and every exam, especially for these purposes, the physical sciences paper 1. And to score now your maximum marks for each paper, you need to be using this tip, that the moment you get your exam paper, make sure that you are planning. Make sure that you are using this tip that says, for every 1 mark, make sure that you spend 1 minute. So if the entire question is out of 20 marks, make sure that you time yourself and give yourself 20 minutes to cover that particular question. And if it happens that a question is taking longer than it should, you can then be able to move on, and then you're going to come back to it later on. So make sure that you structure your questions or structure your responses in such a way that you are starting with all the easy questions first, and then after that, you can come back to all the questions that you deemed to be difficult. Don't forget the tip that 1 mark, 1 minute. If a question is taking longer than it should, stop, move on, and you'll come back to it at a later stage. So now, the structure of your question paper will be always starting with the multiple choice questions. So how do we then answer multiple choice questions? This is the tip that I'm going to give you. Let's say now we have a question like, a ball is thrown vertically upwards, and which one of the following physical quantities has a non-zero value at the instant the ball changes direction? So keyword there is, it's a non-zero. So one of these two options needs to be a non-zero, where at the instant the ball changes direction. And we should now be able to interpret that question that, when does the ball change direction? The ball changes direction at the highest point. That means the ball needs to be thrown upwards, and then at the highest point, it is going to change direction, and then it comes back down. So which one of these will have a non-zero value? So we know that as the ball goes up, it is going up with a certain velocity. So velocity will be decreasing as the ball goes up, and then the acceleration as the ball goes up, remember, it is going to be 9.8 meters per second squared. So the acceleration in the entire flight of the object, it is not going to change. However, at the highest point, the velocity for the object to be able to come back down, the ball needs to stop, or the object needs to stop. And if it stops, that means the velocity is equal to 0. And remember, acceleration in the entire flight is going to be equal to 9.8 meters per second squared, as it is a constant. It is going to be 9.8 meters per second squared. So whenever you're answering questions on multiple choice, the process of elimination, it is going to work wonders for you. Try to analyze the question, see if whether you can interpret it, and thereafter eliminate all the questions or all the detractors in this question, and then choose the correct one. Now, another question again of similar nature. It's a multiple choice questions. We are given 4 options, and there's a question that is asked. The question says, an object is thrown vertically upwards. Which one of the following regarding the object's velocity and acceleration at the highest point of its motion is correct? So we need to be looking at the velocity and looking at the acceleration where at the highest point. So as you are reading now your question, try to check if whether you can identify the keywords, identify the command words, and thereafter you can then be in a better position to answer the question. So the highest point, that's now the maximum height. Now what happens, the ball is thrown upwards, or the object is thrown upwards, reaches maximum height, it stops, it changes direction. In the entire flight of the object, the acceleration, we know that it is 9.8 meters per second squared. But at the highest point, the velocity is going to be 0 meters per second, because it starts with a certain velocity, it's thrown or given the initial velocity, and as the object goes up, the velocity, it decreases up until it gets to 0. So that means at the highest point, velocity must be 0 and acceleration must be 9.8. Now with regards to the direction, remember that acceleration is always acting downwards. Acceleration is always acting downwards. So now looking at the values that we have here, or looking at the options that we have here, We are saying that at the highest point, the velocity must be 0 and the acceleration must always be acting downwards. So that means after having eliminated all the other options, you will find that the correct answer is going to be D, where velocity is 0 at the highest point and acceleration, as we have said, every time the acceleration is always acting downwards. So the process of elimination is going to work well for you and work wonders for you. So now, where do we now score marks if we are given longer questions now, unlike the multiple choice question? So let's say, for instance, you are given this question, question 2, on Newton's laws. We are told here that a block that has a mass of 20 kg, it is resting on a rough horizontal surface. It is connected to blocks P and Q by a light inextensible string that is moving over a frictionless pulley. Block P and Q are glued together and have a combined mass of m. A force of 35 Newton is now applied to the 20 kg block at an angle of 40 degrees with the horizontal as shown in this diagram here. So there's an angle of 40 degrees that is up, and the force of 35 newtons that is applied to the 20 kg block. And then now the 20 kg block experiences a frictional force of magnitude 5 Newton as it moves to the right at a constant speed. Question 1 says define the term normal force. So when you are defining, make sure that all the underlined weights are there in the correct context. If you are going to now omit any of the underlined weights, what is going to happen? You are going to be losing a mark. So now if you omit any of the underlined weights there, there's going to be a penalty of 1 mark. So make sure that the perpendicular force exerted by the surface on an object is there in your definition. And that is going to be getting you 2 marks if you just write those weights in the correct context. It does not mean that you only just need to write only just that phrase, perpendicular force exerted by a surface on an object. It needs to be in a correct context. On an object in contact with the surface. But what we're looking for, it is those underlined weights there. Now 2.2, when we are drawing a labeled free body diagram for the 20 kg block. Now remember, free body diagram, the object must be represented by the dot and all your arrows must be touching the dot. You can't have a dot with a force starting just on the side of the dot. The force that is indicated by the arrow needs to touch the object, which is the dot. And you always need to make sure that you correctly label all your forces. So we have W going down, we have a Fn going up, and then we have friction, and the last force is tension. And when you are labeling it, it's going to be Ft. So take note of all of these criteria here and the accepted symbols when you are drawing your free body diagram. So now coming to the calculation, the long question, where do you score your marks? And just going back quickly on the free body diagram, if you were to count all the forces, there are 5 as per the mark allocation. Remember, 5 marks is going to be equal to 5 forces. If you add an extra force, there's going to be a penalty of 1 mark. So make sure that you look at the mark allocation before you draw your free body diagram. So now going back now to the long question, where do we award the marks? We start now with the correct equation. You copy it as is from the formula sheet, and by so doing, you get 1 mark. Remember, copy the formula as is before doing any manipulation to it. Copy it and then rewrite it in your answer script, and then afterwards, you can then do any manipulations to it. So you're going to get a mark for the formula, and then the mark for the left-hand side substitution, the mark for the right-hand side substitution, and then after, when you're now going back to the FNet, and you expand it in terms of the actual forces that are acting on an object, and then the correct substitution for the tension being the 31.81, you're going to get a mark for it, and the last mark is going to be for giving the final answer, and the total there is also going to be 5 marks. Moving on. Looking at 2.4 now, we are told that at a certain stage of the motion, block Q breaks off and falls down. How will each of the following be affected when this happens? 2.1, the tension in the string. So you need to choose if whether the tension in the string is going to increase, decrease, or remain the same. And the answer there would be to decrease. And then for 2.4.2, the velocity of the 20 kg block, and we also need to explain our answer. So what is going to happen to the velocity of the 2 kg block? The velocity will decrease, and then after, as the tension force decreases, the net force or the acceleration acting on is going to act in the opposite direction of the motion, or you can say it's going to act to the left-hand side. So make sure that all the underlined weights are there. All the underlined weights are there. If you omit a phrase or you omit a certain weight, there's going to be a deduction or a penalty of 1 mark. Now, looking at other questions again, which is question 3. A small ball is dropped from a height of 2 meters and it bounces a few times after landing on a cement floor. We need to ignore a friction. This is what we are told, a command phrase. And then the position time graph not drawn to scale represents the motion of the ball. So we are given the graph, we need to interpret, you need to analyze the graph and then take and extract information from the graph and apply it into the calculation if there is a calculation here. The first question though says we need to define the term free fall. Now remember, when we are defining free fall, we are looking for gravitational force only. Gravitational force only. Remember, gravity is no longer accepted. Gravity is no longer accepted, but we are looking for the gravitational force only. Or you can say the motion in which the only force acting on an object is your gravitational force, or you can talk about the weight. Now remember, the other important key weight there is only. It needs to be the only force. You cannot say the force acting on an object is gravitational force. Only needs to be there. If you say the force acting on an object is gravitational force, you should finish up with only. Gravitational force only. In addition to that, when you look at question 3.2, the time that the ball is in contact with the floor before the first bounce. So for the 2 marks, you need to now analyze your data and check which one is correct. Now, the answer there, it is going to be 0.03 because we are analyzing the data that is given to us. We look at the first bounce and look at the second bounce. This is your first bounce and that is going to be your second bounce. And then you calculate the difference between those 2 times and you get your 2 marks there. Again, the important thing would be the unit for time. It is seconds. Then with 3.2.2, we need to now look for the time it takes for the ball to reach its maximum height after the first bounce. Key phrase there is the maximum height. So there are different options in calculating this particular question here, and it is 2 marks. And remember, if you are using the equations of motion, copy them exactly as they are from the data sheet, and then you can manipulate afterwards. But then if you were to use option 2, for instance, the formula will not have any mark, but the substitution is going to be a mark there and also for the correct answer. And then again here, the differences between the 2 times that you are getting from the graph at dividing by 2 and then the final answer, that's how you're going to be marking this particular question here, and it's 2 marks. Moving on. With 3.2.3, looking for the speed at which the ball leaves the floor at the first bounce. So again, remember we said this is your first bounce here, and you're looking for the speed at which the ball leaves the floor. So basically the speed with which the ball rebounds off the floor after the first bounce. So how do you mark it? We are looking at the correct formula, the correct substitution, and also the answer. Now there is a range here. Should you get anything between 5.94 and 6.08, you're going to get the full mark for the answer. But if now your answer comes out to 6.1, now 6.1 is now bigger than the limit of the range, because the limit there must be 6.08. If you're getting 6.01, that means you made a mistake somewhere in between the calculation. So where do you award the mark? It is the mark for the formula, the mark for the entire substitution as it is all underlined, and then after the mark for the final answer. Remember, take note of the range that your answer must fall in between those 2 numbers. It can be smaller than 5.94 and also can be bigger than 6.08. Now remember, this is done to take into account the rounding off that certain people do. So you remember that you need to read your instructions. They are always telling you that you need to round off at your final answer. Don't round off in between, only in your final answer. Now with, again, question 3.2.4, we're looking for the time indicated on the graph. So if you go back onto your graph, there's going to be the time that is indicated t, and that's what we are looking for, that time there. So the calculation now would be 1 mark for the formula, 1 mark for the left-hand side substitution, 1 mark for the right-hand side substitution, and then after that, you add the times that you are finding in your graph, and therefore the final mark there. So the total for this question is going to be 6 marks. So remember, with regards to the vertical projectile motion, you are allowed to choose direction. You can either choose downwards as positive or you can choose upwards as positive. So with whichever direction that you are choosing, the mark allocation is going to be the same. It's the formula, left-hand side substitution, right-hand side substitution, the addition of those 2 times, and also lastly, the last mark would be for the final answer. With regards to question 4 now, we are told here that ball P of mass 0.16 kg, it is moving east. Take note of the direction. At a speed of 10 meters per second, it collides head-on with another ball Q that has a mass of 0.2 kg that is moving west. So we have 2 balls here that are moving in opposite direction and they are of different masses. So ball Q, it is moving at a speed of 15 meters per second, and then after the collision, ball P moves west at a speed of 5 meters per second as shown in the diagram. Question 1 says we need to define the term momentum in words. Again, defining momentum, we are looking for specific keywords, and they must all be in the correct context. You can either say the linear momentum, or you can just say the momentum of an object. It is the product of mass and velocity. So you can say momentum is the product of mass and velocity. So all the words that are in bracket, even if you do not write them, but then as long as the sentence is in the correct context, you're still going to get your full 2 marks. And then when you're looking at question 4.2 now, we are to calculate the velocity of ball Q after the collision. So the 2 balls have collided and then the other one moved west. So now we are going to be looking for the velocity of ball Q after the collision. Mark allocation, number 1, we copy exactly as is from the formula sheet before doing any manipulation. By so doing, you get a mark there. You're also going to get a mark for the left-hand side substitution, a mark for the right-hand side substitution, a mark for the answer, and a mark for A for the direction. Now remember that momentum is a vector quantity. It needs to have both the magnitude and the direction, which is why you have the magnitude and the direction. Each one of them has its own mark. So make sure that you always keep in mind that we have scalar quantities and we also have the vector quantities. For all the vector quantities, make sure that you write that direction. With question 4.2, we are now to calculate the magnitude of the impulse on ball P during the collision. Again, how do you mark? Formula sheet. Copy as is, you get a mark. There's going to be a mark for the substitution and then a mark for the final answer. Remember we said momentum is a vector quantity, there needs to be direction. So because of that, we can choose or if you have chosen that west is going to be negative or west is going to be positive, the way in which you substitute is going to be different. However, the final answer and the way in which we allocate the marks is going to be the same. 1 for the formula, 1 for substitution, and then the last one is going to be there for the final answer. And that's going to be your 3 marks. So now looking at question 5, work, energy, and power. The question says, a roller coaster car of mass 200 kilograms with the engine switched off travels along track ABC, which has a rough surface as shown in the diagram. At point A, which is 10 meters above the ground, the speed of the car is 4 meters per second. at point B, which is at a height of h above the ground. The speed of the car at that height, it is 2 meters per second, and during the motion from point A to B, 3.4 times 10 to the exponent of 3 joules of energy is used to overcome the friction. And we need to ignore the rotational effects due to the wheels of the car. So that's the diagram, and the questions would be: number 1, we define the term non-conservative force. The most important thing there in your definition is all the words that are underlined. And remember, you do not just write the underlined words. It must be in a correct context for you to get the full 2 marks. For question 5.2 rather, we are to calculate the change in kinetic energy of the car after it has traveled from point A to point B. So how do we allocate the marks? Number 1, it's from the formula sheet and formula. It is going to be for the substitution, and then the last one is going to be for the final answer. So always remember to copy your formula sheet exactly as is, the formula exactly as is from the formula sheet. Question 5.3, we are to use energy principles to calculate the height h. Key phrase there is energy principle, so we can't use anything else. Even if a different equation can be used to calculate the height, the instruction there says energy principles only. So how do we now award marks there? So we're going to have 1 for the formula, 1 for the left-hand side substitution, 1 for the right-hand side substitution, and the final mark will be on the answer. Now remember, we can also accept this one given here. You can either use option 1 or option 2, but then the mark allocation is going to be awarded in the same manner and the same context again. With regards to question 4, we are to calculate the power delivered by the engine to move the car from point B to point C. So it's question 4 of question 5, so it's 5.4. Number 1, we are going to get 2 marks for the formula, 2 marks for the left-hand side substitution, and 1 mark for the right-hand side substitution. So that is what we are going to have in our calculation here. So you're going to get 2 marks. You're going to get 2 marks for the formula, 2 marks for the left-hand side substitution, and the last mark is going to be for the right-hand side substitution, and that's how you're going to get your 5 marks for this particular question. So before we go to the next part of the question, let's quickly go for a short break, and I will see you just after this. Welcome back, learners. So now to go back, we are looking at question 6 now. And this is the Doppler effect. The question that says, the siren of a train moving at a constant speed along a straight horizontal track, it emits sound with a constant frequency. A detector placed next to the track records the frequency of the sound waves, and the results obtained as shown in the graph alongside here. So we have a graph that was drawn based on the results that we obtained from the detector. Question 1 says, state the Doppler effect. What we are looking for there is the change in frequency. And then again, the sound and the listener have different velocities relative to the medium of propagation. Remember, keywords, all the underlying keywords there, they must be there in your statement. You must always make sure that they're always in a correct context. You don't just write only the underlined words, you write everything, but make sure that those ones are there and in the correct context. Question 6.2. Does the detector record the frequency of 3,148 Hz when the train moves towards the detector or away from the detector? So the answer for that question would be towards. Now, moving on to the next part of the question 6.3, we are to calculate the speed of the train, and we must take the speed of sound in air as 340 meters per second. So how do we allocate marks there? It's 1 mark for the formula, 1 mark for the left-hand side substitution, 1 mark for the right-hand side substitution. Remember, we can either use this or that formula. And then afterwards, we are going to have a mark again there, a mark there, and then the last one is going to be for the final answer. And the total there is going to be 6 marks. So the formulas that we can use, make sure that this one, we are taking it as is from the formula sheet, because these ones, these two, are the manipulated versions of that one. We start by taking the correct one from the formula sheet before we manipulate anything. And then 6.4, the detector started recording the frequency of the sound of the moving train siren when the train was 350 meters away. We are to calculate T1 that is indicated on the graph. So we have T1 there. So how do we allocate marks? There is no mark for formula, but 1 mark for substitution and 1 mark for the final answer. So in any of these 3 options, there is no mark for formula. It's just the substitution and the final answer. But remember, we substitute in the correct formula so that we can get the correct answer. With question 7, we are told there that 2 small charged spheres A and B are placed on insulated stands which are 0.2 meters apart as shown in the diagram below. They carry a charge of -4 times 10 to the exponent of -6 coulombs and +3 times 10 to the exponent of -6 coulombs respectively. And we also told that M is a point that is a distance of 0.1 meters to the right of sphere B. And with all of that, question 1 says we need to calculate the number of electrons in excess on sphere A. Equation from grade 10, 1 mark for substitution and 1 mark for the final answer. Equation, correct substitution, and the final answer. 7.2, calculate the magnitude of the electrostatic force exerted by sphere A on sphere B. Again there, the Coulomb's law, 1 mark for the equation, 1 mark for the entire substitution. Make sure everything is correct, and also the last mark is going to be for the final answer. 7.3, we now need to give a description for the term electric field. And that is now a region, is a region in space or a region where an electric charge or a charge experiences an electric force, or you can just talk about the force. Now remember, all the underlined keywords are supposed to be in your description in the correct context. It's either 2 marks or nothing. Question 7.4. We are to calculate the magnitude of the net electric field at point M. How do we mark? There's no mark for the formula, but there's a mark for the substitution, a mark for the substitution again. This is for force A to M, B and M. There's 2 marks, 1 mark for each substitution, and then another mark there, and then there's going to be a mark for using the electric field equation, and then lastly, the mark for the answer. The direction there's no mark for it, but then remember, vector quantities must have both magnitude and direction. So write the direction even though there is no mark for it, but you make sure that you are writing it, and the mark allocation for that question would be 5 marks. Looking at 7.5 now, we are asked, is the charge on sphere D positive or negative? The answer for that is going to be negative, positive rather. And then for 7.6, we need to calculate the magnitude of the charge on sphere D. How do we mark there? There's no mark for the formula, because this formula, we do not get it in the formula sheet, but the substitution is a mark. And then using the Coulomb's law, there's no mark for the formula, but the mark for a substitution into the correct formula. And then the last one would be for the final answer. And that's how you get your 3 marks. With regards to question 8, question 1 says we need to define the term EMF of a battery. We are given an electric circuit alongside, and question 1, we are to define the EMF of the battery. So that is now energy provided or the work done by a battery per coulomb or per unit charge passing through it. The underlined phrase is very important in your definition. So again here, it's 2 marks or nothing. Make sure that the underlined words are written in the correct context. Then question 2, the reading on the voltmeter decreases by 1.5 volts when switch S is closed, and we are to give a reason why the voltmeter reading decreases. So energy per coulomb of charge is converted to heat in the battery due to the internal resistance. This is very much important also to write, and you get your 2 marks there. And then 8.3, we are to calculate the reading on the ammeter with switch S closed. 1 mark for equation, 1 mark for substitution, and 1 mark for the correct answer. Then 8.3.2, calculating again the total resistance of the circuit, would be 1 mark for the formula, 1 mark for the substitution, and 1 mark for adding the 4, and then the last mark would be for the final answer. So it's the formula, substitution, and adding the 4, and then after adding the 4 you get your full marks. And also note the range, there, that even this is also going to be accepted. And if you are to calculate the EMF of the battery for 3 marks, it's 1 mark for the formula, 1 mark for the entire substitution, and then 1 mark for the final answer. Again, take note of the range, that your answer must be in between those two numbers. It can be smaller than this and also can be bigger than 41.64. So for either of the two options, it is going to be 1 mark for the formula, 1 mark for the substitution, and lastly, 1 mark for the correct answer. With 8.4 now, we are told that a learner makes the following statement. The current through resistor R3 is larger than the current through R2. Is this statement correct? We need to choose from yes or no, and then after we explain our answer. So the correct answer, the correct option would be yes. And then in explaining that answer, we say for the same voltage or for the same potential difference, a mark, a larger current will flow through a smaller resistor. That's going to give you your second mark in the explanation. So the total for that would be 3, 1 for answering the question, and then after the 2 marks for the explanation. And then question 8.5, the 4 ohm resistor is now removed from the circuit. How will this affect the EMF of the battery? We need to choose from increase, decrease, or remain the same. And the answer for 8.5 is remain the same. With question 9, we are given a diagram there and asked questions on it. A simplified diagram of an electrical machine is shown alongside. Is this machine a DC motor or a DC generator? So this is going to be a DC motor. You're also going to be correct if you just write motor and eliminate or not write DC. You're still going to get your mark there. For 9.1.2, we need to write down the energy conversion that takes place while this machine is in operation. So this is now moving or changing from electrical energy to mechanical energy, or to kinetic energy, from electrical to kinetic, or you can talk about electrical to mechanical, and then you get your 2 marks. And then write down the name of component A in the diagram. You must know the components of this motor here. And on this motor, the component A is given there, and that is going to be split ring, or you can say a commutator. With 9.1.4, in which direction will the coil that is shown in the diagram rotate? We need to choose from clockwise or anti-clockwise, and the correct answer there would be anti-clockwise. In addition to that again, 9.2, we are told that an electrical device is marked 200 watts and 220 volts. With that given, we need to define the term RMS voltage. So again, in your definition, make sure that all the underlying keywords there are there. If you omit any of the key phrases or any of the keywords, there's going to be a penalty. 1 mark is going to be deducted. And then for 9.1.2, calculating the resistance of the battery. For 3 marks, 1 mark for the formula, 1 mark for the correct substitution, and 1 mark for the final answer. So with any of these 3 options, it's going to be formula, substitution, and the correct answer. So if you are choosing these 2 options, the second mark is going to be given to the substitution that is leading to the answer. So nowhere before you're going to get only the mark to the substitution that is leading towards the final answer. Now, with regards to the next question, 9.2.3, calculating the energy that is dissipated by the device in 10 minutes. It's 1 mark for the formula, 1 mark for the substitution, and then you get an answer there that you're going to use on the next part, and another mark for the formula, another mark for the substitution, and the last one is going to be for the final answer, and then you get your full 5 marks. Looking at the last question now, question 10, an experiment is conducted to investigate the relationship between frequency of light on a metal and the maximum kinetic energy of the emitted electrons from the surface of the metal. This experiment is conducted for 3 different metals, and the graph here represents the results that are obtained. We have 3 metals, potassium, zinc, and platinum. And with that said, question 1 says we need to name the phenomenon on which this experiment is based. Writing photoelectric effect, that's your 1 mark. Question 2, name the physical quantity represented by X on the graph. So going back to your graph, what is represented by X would be your work function. So work function of potassium, you can either say work function or you can say work function of potassium to get the mark there. And then for question 10.3, which one of the 3 metals needs incident light with the largest wavelength for the emission of electrons? And we need to give a reason for your answer. Again, this answer is going to be based on your interpretation of the graph, but the correct answer would be potassium, and then your explanation or your reason for choosing potassium should be it has the lowest work function, or you can say it has the lowest threshold frequency, or you can say it has the highest threshold wavelength. So any of those ones would be correct, and remember, by choosing the correct metal is also going to be giving you a mark. With 10.4, defining the term work function, again, we are looking for the keywords. The keywords are needed in the correct context. So if you omit any of those words, it's either going to get 0 or there's going to be a mark being deducted in your definition. And then with regards to the calculation, calculating the work function for platinum, number 1 would be for the formula, for the substitution of the threshold frequency, and then also the final answer there. So if you're using this equation or using this equation, it's 1 mark for the equation, 1 mark for the correct substitution, and the last mark is going to be for the final answer. And please remember that an answer without units is incomplete, and therefore you're going to lose a mark if you're not writing any units. Now, looking at the last question here, we are told that the frequency of the incident light that will emit electrons from the surface of platinum with a maximum velocity of 5.64 times 10 to the exponent of 5 meters per second. So calculating that frequency of light, first mark from the data sheet would be 1 mark for the equation, 1 mark for the left-hand side substitution, and 1 mark for the right-hand side substitution, and the last one is going to be for the final answer. Remember, with the correct units of frequency, or with the correct unit of whatever variable that you are calculating for. So before now we go to the next part, let's quickly go for a short break, and I will see you just after this. Welcome back, learners. So now just to round up everything that we've gone through in this entire lesson, always remember the following, that number 1, use the reading time that you are given. That 10 minutes is very important, use it. And when you are doing any calculations, make sure that you do not provide 2 solutions. Make sure that you provide 1 solution and stick to it, and make sure that it's clear with the correct units as well. And then always copy the formula as it is from the formula sheet. Remember, do not manipulate before writing it. Copy it exactly as it is from the data sheet, and then after having copied it, you can then do any manipulations to it. And importantly again, you need to relax and believe in yourself whenever you're writing any exam. Be prepared mentally and physically. You need to have enough rest before you write your paper. And I wish you all the best. Until I see you next time, goodbye.